With advancements in science and technology, we can easily access most things from around the world. However, some substances are so rare and costly that everyone in the world would need to work for 1 year straight to afford 1 gram. Today, we'll explore why some substances are so expensive and, more importantly, why they are so hard to obtain. But before we start, I'd really appreciate it if you decided to support me on Patreon. Supporters get behind-the-scenes footage and choose which topics I'll cover next. And if you're interested in science and technology, subscribe to this channel so you never miss another video. Without further ado, let's take a closer look at the most expensive substances in the universe. Number 10. Palladium. $34.21 per gram. Palladium is a precious metal used in electronics and vehicles. Its main use is in catalytic converters, which transform toxic and harmful chemicals emitted by gasoline combustion into more environmentally friendly substances. In the electronics industry, it is used primarily in the production of microprocessors and printed circuit boards. The high demand in both of these fields, combined with its rarity, contributes to its high price, which is slightly lower than gold's. Number 9. Asian rhino horn ivory. $400 per gram. While not necessarily a substance, Asian rhino horn ivory is one of the most expensive items you can buy on the market, or more precisely the black market, as it is illegal to hunt rhinos and harvest their horns. The main demand for this resource is in East Asia, where traditional medicine claims that the horn has outstanding medicinal properties, despite a lack of scientific evidence. The rarity of rhinos due to habitat loss and hunting, combined with high demand, results in an astronomical price for something that doesn't actually heal and works more like a placebo. Number 8. Lysergic acid diethylamide, LSD. $2,500 per gram. Lysergic acid diethylamide, more commonly known as LSD, is a powerful psychedelic drug that played a significant role in the hippie culture of the 60s. It is believed to have healing properties in psychiatry, particularly for treating addictions, and there are claims that it has stronger pain-killing properties than opioids, which can be highly addictive. LSD was legal for some time and was even used in various tests by the US government. In one such test, soldiers were given a dose of LSD to assess their combat skills under its influence. The test ended after one soldier climbed a tree and began feeding birds that were chirping on it. LSD was made illegal primarily to combat the counterculture movement of the 1960s, which was strongly opposed to the government. Its complex synthesis process, the difficulty in obtaining the necessary chemicals for production, and its legal status make LSD one of the most expensive drugs in the narcotic industry. Number 7. Tritium. $30,000 per gram. Tritium is an isotope of hydrogen with 2 additional neutrons in its nucleus. This property makes it useful in fusion reactors, which are being heavily researched for their potential to generate large amounts of electricity at a low cost. The challenge with tritium is its rarity. For every 100,000 hydrogen atoms, there are only about 500 tritium atoms. This scarcity, combined with high demand in the fusion reactor industry, results in its extremely high price. Number 6. Diamond. $50,000 per gram. Everyone knows what a diamond is, the most popular and desired gemstone in jewelry. However, its price isn't directly correlated to its rarity, as many might think. The diamond market is highly regulated by the countries that mine these gems, ensuring that prices remain high. Diamonds also find uses in other industries. Being the hardest material on Earth, they are often used in tools required for cutting or polishing various materials. Number 5. Red diamond. $1.2 million per gram. We've talked about normal diamonds, now let's discuss their rarer counterpart, the red diamond. Unlike normal diamonds, the price of red diamonds is driven solely by their rarity. As of 2023, only 23 red diamonds have been found. The red color of this gem results from deformations in the crystal structure, which allow red light to be the most visible on the spectrum. Number 4. Californium, $27 million per gram. Now we're talking. At $27 million per gram, californium is one of the most expensive substances in the world. It is produced artificially in nuclear reactors and can also be found at test sites after nuclear detonations. Californium is one of the few transuranium elements with practical applications. It is primarily used in the nuclear industry as a neutron emitter, with just 1 microgram, producing up to 139 million neutrons per minute. It is also used to artificially create other elements, such as the recently discovered oganesson. However, californium is extremely dangerous. If it enters the body, it settles in the bones and continuously emits radiation, which can be lethal over time. Number 3. Endohedral fullerene, $140 million per gram. Endohedral fullerenes are a fascinating class of carbon molecules, where other atoms or clusters are trapped inside a fullerene cage, a hollow, spherical structure made entirely of carbon atoms. The unique properties of endohedral fullerenes make them extremely valuable for advanced technological applications, like in quantum computing, where they hold potential due to their ability to exhibit quantum mechanical properties at a molecular level. The encapsulated atoms can serve as qubits, the basic units of quantum information. information, offering unprecedented computational power and speed. They are also being researched for use in drug delivery systems, where they could precisely target diseased cells, minimizing side effects and improving treatment efficacy. The synthesis of endohedral fullerenes is a highly specialized and labor-intensive process involving the encapsulation of atoms inside fullerene cages. This, combined with their cutting-edge applications and ongoing research, justifies their astronomical price. Number 2. Polonium-209, $49 billion per gram. Polonium-209 is one of the most expensive and rare radioactive elements on Earth. It has significant applications, but its production and handling are fraught with challenges. Polonium is used in specialized scientific experiments, particularly in studies involving alpha radiation. Its high alpha particle emission makes it valuable in nuclear physics research. Additionally, though limited, polonium-209 can be used in devices designed to eliminate static charges in manufacturing processes, particularly in the textile and paper industries. The extreme cost of polonium-209 is due to its production process, which typically involves neutron irradiation of bismuth-208 in a nuclear reactor, followed by complex chemical separation processes. Additionally, the handling and storage of polonium-209 requires stringent safety measures due to its high radioactivity, further increasing its cost. Number 1. Antimatter, $62.5 trillion per gram. Antimatter represents the ultimate in rarity and expense. It consists of particles that are the mirror counterparts of ordinary matter particles, such as positrons and antiprotons. When antimatter comes into contact with matter, they annihilate each other, releasing energy according to Einstein's equation, E equals mc squared. This process could, in theory, provide an incredibly efficient energy source. Even a small amount of antimatter could release immense amounts of energy, far surpassing conventional energy sources. Antimatter's energy density also makes it an attractive potential fuel for long-distance space travel. A spacecraft powered by antimatter could reach speeds much higher than those achievable with current propulsion systems, significantly reducing travel time to distant planets and stars. The production of antimatter is a monumental challenge. It requires particle accelerators, like those at CERN, to produce and capture tiny quantities of antimatter. The process is extremely energy-intensive and inefficient, with current technology producing only trace amounts of antimatter at an enormous cost. Storing antimatter is equally challenging, as it must be kept away from any matter to prevent annihilation, requiring sophisticated magnetic and vacuum containment systems. These factors collectively make antimatter the most expensive substance on Earth. And that's the end of today's video. If you enjoyed it, please like and subscribe so you don't miss any future content. Also, consider supporting me on Patreon for exclusive behind-the-scenes footage and to help decide on future topics. Hope to see you in the next video. Take care!